Now let's segue into talking about interquartile range. First thing we should say is remembering what range is. Range by definition is max minus min. Well, interquartile range by definition is quartile 3 minus quartile 1. So what we need to do is first talk about what are quartile 3 and what are quartile 1 and how do you find them. To find the quartiles, what you're going to do is you need to arrange the observations in increasing order like we did for the median. After you do that, to find the first quartile, it is the median of the observations whose position in the ordered list is to the left of the median. So what they're doing here is if we look back at these 20 pieces of data about the New York travel times, they put the data in increasing order. When you find the median, there isn't one right smack dab in the middle, it's these two, so they added them up and divided by 2 and got the answer. Now, to the left of that is all of this data. In the piece, the number 20 has to actually belong to the lower half. If there's one right smack dab in the middle, then no one gets it, not the lower half or the upper half. Now, to find the median of this, you're just going to cross them off until you get to one in the middle. Again, there's not one smack dab, so you add them up and divide by 2. Therefore, quartile 1 is 15. Okay, now quartile 3. What that is, says here, quartile 3 is the median, of the observations, whose position in the lower list is to the right of the median. So we're talking those on the upper half. So if we look at this data now, if we take this upper half of the data, and we start to cross off, what's going to happen are these two are in the middle. You take the average and you'll find quartile 3. So basically what we did is we quartered the data off. So whatever piece of data is in the middle is in the 50th percentile. Whatever piece of data lands at quartile 1 is in the 25th percentile. And in quartile 3, that piece of data is the 75th percentile. So if you start to think about where the data sits, the data, anything from the 75th or quartile 3 on up is the top 25% of your data. Anything at quartile 1 and below is the bottom 25% of your data. Now let's take a look at range and interquartile range with that same data set that we had. If we compute the range for this, obviously the range is 50 minus 1 or 49 in this case. The interquartile range, we do need to find quartile 3 and quartile 1. So let's go ahead. If we find the median here, the median is 2. Therefore, our lower half of our data is right here. The middle of that is 1. So quartile 1 is 1. The upper half, the middle is that, it's going to be 3. So quartile 3 is 3. Therefore, IQR is interquartile range is 3 minus 1 or 2. Now, the question here is range or IQR a resistant measure of spread? Which one of these two numbers is less influenced by outliers? Well, if you look at this data set, most of this data set is just single numbers. But when you pop in the outlier 50, who gets the most impacted? Clearly, the range is the most impacted. So which one is considered to be a resistant measure? The IQR is the most resistant to outliers. Another way you could do this is to actually recalculate the IQR without the outlier in there. So if you removed 50 and you did the IQR on this, the actual IQR comes out to being the exact same IQR as it was before. So IQR without the outlier equals 2. Versus if you were to remove the outlier and recompute the range now goes from 3 minus 1 and becomes 2 itself. So the range completely changed. Therefore, this is non-resistant to the outliers versus the IQR is resistant to the outliers. Now, the last thing they want us to do is looking at these 3 measures of spread to rank them. 1 with being who is the most resistant to outliers, and 3 is the least resistant. Well, the least resistant here is range, so that's 3. That IQR is the most resistant. And I will tell you, we haven't talked standard deviation yet, but that one is going to be in the middle. So let's look at one comprehensive example here and wrap up our notes. McDonald's beef example here, we have a data of all of the fat contents in their various beef sandwiches. So from the hamburger all the way to the Angus Deluxe, this is the fat content. They want us here to create a stem plot of the data. So if you take a look at this, there's a nice stem plot that I did. Remember, don't leave any of the stems out, put everything in increasing order, and have a key. Okay. Part A here wants us to find the mean amount of fat for all 15 sandwiches. So if I use my calculator, I'm just going to, remember, hit the stat button and do edit. When you do that, I'm going to put the data in the list. Then I'm going to go back to stat, calculate a one variable statistic. I'm in list 1. When I do that, here are my results. So we can actually see the mean value is showing up right here is the average fat content. So we have 26.2 grams as the average fat content. Next question, the 3 Angus burgers are relatively new additions to the menu. How much did they increase the average when they were added? Well, the best way to figure this out is just to go back into the data and actually remove the 3 Angus burgers. So we're no longer dealing with 15 burgers, but to actually deal with 12 burgers instead. And when you do that, what you're going to end up finding is that the total fat we had before was 26.2. When you remove the 3 Angus burgers, the fat content is now 23 grams on average. So there was a decrease of 3.2 grams on average amongst the beef burgers. Part C, find and interpret the median. If you go back to the calculator output for this, what you're going to find is that the median came in at 26 grams of fat. You want to be able to define that though. What does it mean? It means this. About half of the beef sandwiches at McDonald's have less than 26 grams of fat, and about half have more than 26 grams of fat. And do know this, on a standard free response, if you were asked to compute the median, they're probably going to ask you to actually define it more so than just to compute it, because they're challenging you on understanding the true definition of median and mean. Continuing on, find and interpret the quartile 1 and quartile 3. Just look at the calculator output. You're going to find that the median of the 7 sandwiches to the right of the median, so that means on the upper half, so here we're actually talking about quartile 3, is 39 grams of fat. Okay. The other part of this definition, therefore, would be that the median of the 7 sandwiches to the left, which is going to be quartile 1 of the median, in this case had 19 grams of fat. Now another way you could say it though, if you wanted to for this quartile 3, interpreting that is that the top 25% burgers had 39 grams of fat or more. The bottom 25% of the burgers had 19 grams of fat or less. Now find and interpret the IQR. So we're going to take Q3 minus Q1. And what we're going to get is this. The final answer we know is going to be 20 grams. So to complete this, the range of the middle 50% of amounts of fat for the McDonald's beef sandwiches is 90 grams. And if you look at the data this way, if the data was lined up in increasing order, we know the middle piece of data is the median. The data in the lower half, the median of that is quartile 1. The data in the upper half, the median of that is called quartile 3. So hopefully you can see that this is chunked off into 4 pieces. That's why it's called a quartile. So the definition of interquartile range is what they're saying here is that the middle 50% of the amounts, this is the interquartile range between Q1 and Q3. That's where the middle 50% of the data sits.